This video is to help with test 2, or the quiz in class. This video is going to be slightly different than the others in the sense that I'm not going to be going question by question. I'll just show you each group a question, do one example, and then move on. So you're welcome to watch the whole thing or just skip to the section that you need help with. Questions 1 and 2 look exactly the same. So if I switch to either one, you see that they're exactly the same. They've got 3 graphs. Now in these, you want to ignore the equations. The equations are there to show you what's been graphed, but it's easier to tell these answers based on the graphs themselves. Okay, so here's our graphs. When two lines, let's go with this one. When two lines are intersecting, like this, then we see that there is a point where they have a common answer, one answer. So when they pass once with each other, or pass through each other, or intersect once, that means that they have one unique solution. And that solution is wherever they cross. So if I were to look at just where they cross, I can see right there at -1, -1. So that's going to be what I put here, -1, -1. And so that's that unique solution. Now over here it says, is it consistent dependent, consistent independent, inconsistent? Well, I always forget the consistent thing, and I just remember, is it dependent or independent? In this case, I see that they are 2 separate independent lines that form a common answer at one point, but they are independent. So that would be my answer there. Now, if I look at the bottom, I see that graph creates one line right here, and I'm not drawing it very straight, but it's line 1 and line 2. Okay, and we can tell that by right there and right there. So see here, it gave us, that was line 1, and the other one down here was line 2. Well, here it's telling us that they're the same line. So if I move line 1, well, line 2 is going to go with it because they're the same thing. They are dependent on each other. Just like that. Dependent on each other. And if you look, they don't just meet once, like in the second one here, they meet on every single piece of that line. That means that they are all the common answers, or there are infinite many solutions. Okay, that means that no matter what decimal, fraction, or whole number I put in, it's going to be the same answer for both lines because they're the same line. Well, with that same thought, where this was a unique solution and independent, up here I have 2 parallel lines. These will never, ever, ever cross. So that means that there is no solution. The only solution to a system is where they cross. And this is inconsistent. Okay, there's many different ways of remembering that, but one may be, hey, in math we always have an answer, so it's inconsistent to not have an answer. Or we constantly look for an answer. If there isn't an answer, that's inconsistent with what we're looking for. The way I look for it is, if you don't get an answer, you get frustrated and think you did something wrong. So like in the movie The Princess Bride, you think, inconceivable.
Inconceivable. Inconceivable! 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 Inconceivable!
You keep using the word. I don't think it means what you think it means.
So, however that helps you. But that's how you do number 1 and number 2. So number 2 is the same thing. Number 3, all we need to do in this one is just graph the system. Okay, that's our first step right there. Graph the system. And then write its solution. Well, the solution is just wherever the two cross, right? That's the solution. Wherever the two lines cross. So let's go ahead and graph this one. It's in the y equals mx plus b format, where this right here, this part, is my y-intercept. So let's just go ahead and put a point right there at -1, or +1, excuse me, +1. So our y-intercept is right here. We cross the y-axis at 1. We're going to put a point right there. Now the m, or this part right here, is my slope. And if it's not in a fraction, you just draw a line and put a 1 under it. In this case, it's a 1, 2. So we go up 1 and over 2. So from here, up 1 over 2. And put another point. And we see that's now our first line. Just like that. Try to remember that slope is always how far up or down I go over how far right or left I go. Alright, so next we look at this equation. Well, we see that it's not in slope-intercept form, and there's two ways to solve this, and I'll show you both ways. One is to solve for y. We want to get y by itself, so we're going to minus 2x, and that gives us y equals -2x plus 6. The end there we can't combine, so we keep those separate. So now we have our y-intercept of +6. So I'm going to put a point right there at +6. And our slope is -2. And we don't have a fraction here, so we can just draw a line and put a 1 under it. Now this negative can go with either the 2 or the 1. In this case, this program won't let me go up 2. So I'm not going to put it right there. I'm going to move it down here to the 1. And with that, I'm going to go, excuse me, it will go with the 2. I was thinking of another problem here. So cancel that. I'm going to put it with the 2 and not the 1. But you see, if I did that, I could go up to -1. But in this case, I can't go up 2. So I have to go down 2 and +1. Okay, like that. So I'm going to put another point right there, down to +1, and draw my line there. And we see right here they combine, and that tells me that's the solution. So with that, I can say the solution is x is 2. So I would put my parentheses with 2, comma, and y is 2. Remember, it's always x, comma, y. So that's how you do the questions like 3. Always just graph it first. Don't try to do substitution. These ones, it's easier to graph. You got to graph them anyway, so you might as well just do that first. So that's how you do 3, and I believe 4 is exactly the same. And 5. This one, solve the system of equations. We have 2 of them that are currently solved for y. So that means I'm going to take this y, and what is y equals? Y equals this right here. And I can plug that in right there for that y by rewriting this equation with parentheses wherever the y is. And I'm choosing the y because that's what I'm solved for. So I've got parentheses equals 7x plus 13. All I did was rewrite the second equation, the one that I'm plugging into, with parentheses instead of a y. Okay, now here's my y again, everything after that equal sign, so that's what goes in here. 3x plus 49. And with that, we can now just distribute. There's nothing here, so I'll just distribute a 1. 1 times 3x is 3x. 1 times 49 is 49. Now I've got an x on both sides, so I'm just going to minus one of them, giving me negative 4x plus 49 equals, and this went away, so I have 13. Now I'm going to minus 49, and I'll use a calculator to figure that out. 13 minus 49 is negative 36, so I have negative 4x equals negative 36. Divide by negative 4, divide by negative 4, x equals a positive 9. So that's what goes right here. Whatever my, see, I got x equals as my answer, so x equals 9. Now I still have to find a y equals. So I take this x equals and just plug it in right there. Doesn't matter which equation, just in for that x. So I rewrite that equation, 3, and I'm replacing x, so I put parentheses, plus 49. And what went in that x? This 9. So I do 3 times 9, which is 27, plus 49. And that gives me 76. So my y is 76. And that's how you do these types of problems. You just, especially if they're solved for y, you just take one and plug it into the other. Doesn't matter. You can take the top one and plug it into the bottom one, where they're not both solved for y.
Well,
I'm replacing x, because that's what is equal, x equals, so I'm replacing x. So I'm going to rewrite this top equation with the x as parentheses. So I have parentheses, or x, plus y equals 6. What is x equals? X equals 4. So that's what's going to get plugged in right there. So that gives me 1 times 4 is just 4. So 4 plus y equals 6. I'm going to minus 4, y equals 2. So if you have an x and then the other one, you still just rewrite the other equation, the one that's not equal to, with parentheses with the letter that you're trying to plug in, and then solve. And then if you have to plug it back in, you can. This one is still the same thing. I'll help you set it up. Here I'm replacing x. So I rewrite that top equation without the x, and I put parentheses in place of it. So I have 4x plus 3y equals 31. Now what does x equal? That. So that is what goes inside the parentheses. So I have 2y minus 6 and then I just distribute. 4 times 2 is 8y. 4 times negative 6 is negative 24 plus 3y equals 31. And now you just combine the y's. And solve all the way down. And I'll just go ahead and do this one. So plus 24 plus 24, and we get 11y equals 55 divided by 11. Y equals 5. Okay, so that gives me my y. My y is 5. So that's what goes here with the y. But not only that, I now take that and plug it in right there for my y. So I rewrite that problem. 2y minus 6. What is y? Y is 5. So I'm going to put 2 times 5. What's 2 times 5? It's 10. What's 10 minus 6? That's 4. So that means x, this was all x equals 4. And that's what goes there. Number 8, same thing. You're plugging in for y. So you will take the y value and plug it in and solve. Make sure to use parentheses. Number 9. This one's similar, but in order to solve this one, it's easiest to clear out all the fractions. So I multiply by whatever's in the denominator. So times 6 times 2 times 6, that's a times 2, and times 6 times 2. You do it with all of the numbers, not just the fractions. Well, in the fractions, I see a 6 here that can cross off. So that crosses off or cancels out on both top and bottom. The 2 cancels out on both top and bottom, and there's no denominator over here, so that doesn't cancel. So that leaves me with 2x, because I have 1 times 2, and I have 1 times 6, so minus 6y equals 2 times 2 is 4, 4 times 6 is 24. And I do the same thing here. Times 3 times 5 times 3 times 5 times 3 times 5. And I go through and solve these and simplify. So I cancel out the 3's, cancel out the 5's, and there's no denominator here. So I rewrite that one as 1 times 5 is 5x minus, now I get that from right there. I don't change it, I just use what's in the problem. Minus 4 times 3 is 12y equals negative 2 times 5 is negative 10. Negative 10 times 3 is negative 30. So now I've rewritten both of those problems right there. So that means I can ignore these. I don't have to look at them again. Okay? So I choose one of them to solve for y. And so I'm just going to, or x, it can be x. I'm just going to choose this one right here. And I'm going to solve for x. So I've got 2x minus 6y equals 24. And why am I solving for x? I don't know. It seems easy. So I'm solving for x right there. So I'm going to add 6y, and I get 2x equals 6y plus 24, and then divide by 2, divide by 2, divide by 2, and I get x because the 2's cancel out, equals 6 divided by 2 is 3y. 24 divided by 2 is 12. And from here, you have your parentheses that you can now plug in for x. So you take those parentheses and you rewrite the second equation, putting those numbers in for x. 5 parentheses 3y plus 12 parentheses minus 12y, and you solve for y. When you get that answer, you plug that in right here for y. Okay, so you plug that in right there for y. And that'll give you both your answers here. Now number 10. Number 10 and I believe number 11 is the same. You're given two equations and you got to ask, does it have no solutions, one solution, or infinite solutions? Basically, if it's no solution, then the two lines are parallel. Okay? If it has no solution, the two lines are parallel. If there's one solution, then they're different equations. Okay, so you'll have different lines, and where they cross is your one solution. Okay, and infinite many solutions means that they are the exact same line or the exact same equation. So we look at these. Can I make these the same equation? The best way to do this is solve both of them for y or solve both of them for x. Doesn't matter which. And you're just trying to see, are they going to be the same? Well, I can tell you right now, they're not. I've got one negative and one positive, and both positive. So even if on this one, if I solve for y, I'd do minus x, and that'll give me 5y equals negative x plus 9. And if I do the same thing here, I would get 5y equals x plus 1. So right now, I can tell you the slope is going to be different because one's negative, one's positive. The y's are exactly the same. So if I divided by 5, I would have negative 1 over 5 and 1 over 5. So the slopes are different. And this one's 9, this one's 1, which means they have different y-intercepts. So they're not even the same number at all. So that tells me that they have one solution. Okay, well, how do I know what that one solution is? I've got to find out where those two lines cross. So let's go ahead and do that. I have x plus 5y equals 9. I'm just going to solve for x. To do that, all I have to do is minus 5y. And I have x equals 9 minus 5y, or negative 5y plus 9. Great. Now I know what's going in for x right here. So I'm going to rewrite that equation, this one right here, with parentheses around the x. Negative x plus 5y equals 1. And what goes in right there? This piece is x. So I rewrite it. Negative parentheses 9 minus 5y plus 5y equals 1. Now I distribute. That's negative 1 times 9 is negative 9. Negative 1 times negative 5 is positive 5y plus 5y equals 1. Now I add 9 to both sides and combine the two y's. 5 plus 5 is 10y. The 9's cancel out, giving me equals 10. Divide by 10, divide by 10, y equals 1. Great. So I know I'm going to put a 1 right here. We know it has one solution, and that y is 1. Okay, well now what's x? Well, we take this one right here, and we plug it in right there for y. So 9 minus 5, what's 5 times 1? 5 times 1 is 5, and I'm getting that 1 from right here. 5 times 1 is 5, so 9 minus 5 is 4. That's what goes there. Okay, now let's look at this one. If I solve for y, minus x, I get 4y equals negative 1x minus 2. Divide by 4, and divide by 4. Okay, so I have y equals negative 1/4 x minus 2/4. Let's solve for y here. I'm going to add x to both sides. And I have negative 4y equals 1x plus 2. Divide by negative 4, divide by negative 4, and divide by negative 4. So y equals negative 1/4 x, there's an x there, sorry. Y equals negative 1/4 x minus 2/4. They're the same equation. So that means there are infinite many solutions. Okay? And how did I get that? I mean, if you clear that out, I'll have y equals negative 1/4 x plus negative 2/4, which is the same thing as minus 2/4. And the bottom one here, I have y equals negative 1/4 x minus 2/4. The negative just goes out in front. It doesn't matter if it's on the 1 or the 4. It just goes out in front, and you can see they're the same equation. If it had no solution, then maybe something like this would be a 3/4. The slope would be the same, but the y-intercept would be different. So that's how you do number 10 and 11 and 12. Number 13, story problem. All you do is just write it as you read it. A store is having a sale for 2 pounds of chocolate chip cookies and 3 pounds of walnuts equal total cost of $9. 4 pounds of chocolate chips and 8 pounds of walnuts equal $21. How much is each chocolate chip? So C equals the price, and W equals the price for chocolate chip and walnut. How do we solve it? Well, now we just solve one of them for C. So being as this one's on the bottom and it just seems easier, I'm going to minus 8W, and I have 4C equals 21 minus 8W, or you can put negative 8W first, divided by 4, and divided by 4 gives me C equals 21/4 minus 2W. Okay, there's my C right there. So anywhere I see a C, I can rewrite that. That was the bottom one, so now I take the top one and plug it in. 2C, remember that's what I'm plugging in That's what I'm exchanging, so that's what goes into parentheses, plus 3w equals 9. Now I'm taking this amount right here and putting it right there. So 21 over 4 minus 2w. I just get that from this c right here. Let's distribute. 2 times 21 over 4. If I do that on a calculator, I see it's 42 over 4. 2 times negative 2 is minus 4w plus 3w equals 9. Well, 42 divided by 4, if I do that on a calculator, I see that it is 21. Nope, that was 42 divided by 2. I knew that didn't sound right. 10.5, which is 21 over 2. So 21 over 2 minus 4w plus 3w equals 9. I'm going to combine the w's, giving me 21 over 2 minus 1w equals 9. I want to clear the fraction, so times 2 times 2 times 2. And that gives me the 2's cancel out. And to clear the fraction, remember, you just multiply by the denominator. And I see I have 21. 1 times 2 is minus 2w. And 9 times 2 is 18. So minus 21 minus 21, negative 2w equals negative 3 divided by negative 2 divided by negative 2, and negative 3 divided by negative 2 is 1.5. Now you don't want this one as a fraction. I know I always say you got to leave it as a fraction. So we have c equals and w equals something. The reason why we don't want it is because you don't have fractions of dollars. You have cents, and those are always shown as decimals. So in this case, I would the cost for a pound of walnuts is $1.50, or 1.5, right? So $1.50. So I take the cost of walnut and I put it in right there. Okay, 21 divided by 4 is 5.25 minus 2 times 150 is 3, so minus 3. And that tells me the cost per chocolate chips is $2.25. So all I did was plug it in right there and then just simplify. So that's how you do the story problems 13, 14, and 15. Hopefully this helps you get the score on the quiz that you want. Remember, 80% or higher by the next test, and the quiz score will count as your test score. If you have any questions, let me know.